In this video, we are going to study how the production of ultrasonics will be. Okay, so ultrasonic waves are usually produced by the application of magnetostriction effect, piezoelectric effect. Okay, from these two methods, we can produce ultrasonic waves. So now let us see what is the magnetostriction method. So principle of magnetostriction effect. The change in the dimensions of a ferromagnetic or ferrimagnetic material by the application of a magnetic field is known as magnetostriction method. So what is the principle behind the magnetostriction method is whenever we are applying a magnetic field to a ferromagnetic material or ferrimagnetic material, the dimensions will change. So that effect is known as a magnetostriction effect. The change in length is independent of the sign of the field. So whether we are using the field in positive direction or negative direction, that is the length of the change is independent from the sign of the field. But it depends upon the magnitude of the field and nature of the material. Okay, so let us see what's happening. If a rod is placed in the alternating field and the frequency of the alternating current coincides with the natural frequency of vibrations of a rod, then resonance occurs and the rod vibrates vigorously, producing ultrasonic waves. That means whenever we are applying the field, alternating field, and frequency of that alternating current coincide with the natural frequency of the vibration of a rod. So the applied field and alternating current, whenever it matches with the natural frequency of the rod, then the resonance pattern produces. So the rod vibrates and produces a ultrasonic waves. So ultrasonic waves are now emitted from the frequency of vibrations of such a rod. How the frequency will be, that is F equals to 1 by 12 into root of E by rho, where L is the length of the rod, E is the Young's modulus of the material, rho, that is the density of the rod material. So like this we are producing the ultrasonic waves. Let us see how the construction of magnetostriction method will be. A short permanently magnetized rod, that is a nickel rod, which is clamped in the middle between two knife edges. Okay, so we are taking a rod and is clamped between two knife edges. The coil L2 wound on the right hand portion of the rod along with the variable capacitor C forms the resonant circuit of the collector tuned oscillator. So we are wrapping the coil of wound that will around the coil, a portion of long rod, that and also it is connected to a capacitor. Now the coil L1 wound on the left hand portion of this rod. So right hand side we are arranging the capacitor and wounded by, and left hand side we are also wound a coil L1 and that is connected in the base circuit. So coil L1 is used as a positive feedback loop. Okay, this is the construction. Let us see how it will work. Okay, the working of magnetostriction method and arrangement. When EBB is switched on, and that means the circuit is switched on, the circuit L2C in the collector circuit of transistor sets up an alternative current of frequency. So whenever we are switched on the circuit, then the current passes through the L2 circuit, that's a L2C, and the collector circuit of transistor sets up a alternative current of frequency of range F equals to 1 by 2 pi into root of L2C. Okay, so then the coil produces an alternating magnetic field of frequency F along the length of the rod, or so the frequency, the alternating magnetic field is produced along the rod. Then it results that the rod starts vibrating due to magnetostrictive effect, because we are applying the magnetic field by using the circuit. Next, the vibrations of the rod create ultrasonics which are not sent out as shown in figure. Okay, So how the vibrations will be like we are shown in the figure. The ends of the rod will create the ultrasonic waves and sent out like this figure. See how the construction of a magnetostriction method will be. There is a rod and coils L1, L2. We are using a transistor, that is NPN transistor, and using a capacitor. The two ends of the rod will be clamped by knife edges, and for the circuit we are using a high tension battery, and we are using a direct source at the two ends of the rod here. Okay, next, the coil L1 helps in increase the amplitude of ultrasonic waves. So coil L1, which is wounded around the right side, I think it's a right side of the rod, so that helps to increase the amplitude of ultrasonic waves. Now the longitudinal expansion and contraction of the rod or that produces an EMF in the coil L1. So longitudinal expansion and contraction due to the field of a rod that produces the electromotive force in the coil L1 EMF, which is applied to the base transistor. So okay, whenever it expands and contracts due to the field, an EMF is generated along the coil L1. So it increases the amplitude of high frequency oscillations in the coil L2 due to positive feedback. Okay, whenever such type of process is done, the amplitude of high frequency oscillations in the coil L2 that is due to the positive feedback which we are giving. By adjusting C, there is a capacitor, we can tune the developed alternative current frequency with the natural frequency of the rod, and the resonance condition is indicated by the rise of collector current shown in a milliammeter. So we can catch that point. That means we can see the matching of the natural frequency of the rod with the frequency we are applied by adjusting the capacitor C. So to notice the current in the milliammeter. So by noticing that current in milliammeter, when the natural frequency of the rod will match with the applied frequency by varying the capacitor C in the circuit. Now let us see what is the advantages by using this magnetostriction method. At low ultrasonic frequencies, large power output is possible without the risk of damage of the oscillatory circuit. So really it's a very good advantages, because the low ultrasonic frequencies, at low ultrasonic frequencies only we will get a large output. So that is possible without the risk of damage of the oscillatory circuit. And next, the magnetostrictive generator construction, that is so simple and its cost is low. So the construction and its cost is also low due to the components. So that is also a wonderful advantage. And next, limitations. What are the limitations? So it cannot generate ultrasonic of frequency above 3000 kilohertz. So okay, up to 3000 kilohertz we can generate the ultrasonic waves by using this magnetostriction method. So more than that, if we needed more than the 3000 kilohertz, we needed the ultrasonic waves, we cannot produce it by the magnetostriction method. So this is the drawback of this. And we can't get a constant single frequency from these magnetostrictive oscillators. So by these oscillators we cannot get the constant frequency, constant single frequency. Okay, so the frequency of oscillating depends greatly on temperature. So it is also dependent of temperature. Okay, the frequency oscillations is a dependent of temperature. Okay.